All right, so Guy on the ZoomCode Discord server has asked me, just in general, how do I um, find things like the offset of a field in a struct in one Touhou game when I have it annotated in another, because a lot of my, um, there's like 19 games right now in the Touhou series on Windows, and my notes, um, despite all of the work that I've put into them, they are very different in level of completion for various games. So one thing I have in my THRE data repo, it's called TH16RE data on here on my own computer just because I never renamed it. It's not just TH16. I have a Python script here, stats.py. Actually, let me make sure that's in version control. Huh? Oh, it looks like I put some debugging statement in there. Okay, but it is in version control, so the script is there. Let me just get rid of this. Cool. Okay, so the example Guy gave to me was finding the list, the offset you have to use for the list to iterate over lasers. And so, oops, we know that the struct for that, that as the lasers is called laser manager, and I prefix the class names with a Z just as a naming convention. So what this script here does is it looks at my notes and it tells how much of the struct is labeled in each game. So here you can see Touhou 15 is a game that doesn't have any notes for the struct. It's got 0 good bytes. I forget what the difference is between good and work in progress. It might be work in progress, I think, is names beginning with an underscore. Yeah, I think that's it. But so, basically, we can see it's annotated pretty well in these games. So let's open up both one of these games. Let's take Touhou 16 because it's closest to Touhou 15. Oh no, actually, this has the same size in all of these, and I would like an example where the offsets are likely different. So I'm going to pick, let's say, we want to find the offsets in Touhou 14, given that we know where everything is in Touhou 17. So I'm going to open up Touhou 17, my binary ninja database, which my notes are generated from my binary ninja databases. So the amount of completion in my THRE data repo reflects how complete my BNDBs are. So the other game that we wanted to do was 14? Yeah, 14. All right, so in Binary Ninja, there is a very useful thing right now. Okay, so I have a filler here. This is actually not necessary anymore. I think, yeah, Binary Ninja now automatically fills in large gaps with a padding. Although that might not be entirely convenient because there's, can I expand the padding? Sorry, I haven't used... this has been added since after the last time I used Binary Ninja. Basically, Binary Ninja has these offsets right here with crossrefs. And this is a very easy way to find similar things between different games. Because, for instance, Laser Manager, so like on tick, we can see this thing is stored in game thread start. And this is a method that's always going to be named in basically every game. The methods that you can expect to always be named are anything that's like thread start, on tick, on draw. So like Laser Manager on tick. You will always see that it is labeled, because the first thing I do when I reverse these games is I go through the list of on ticks and on draws, and I label these methods. So these are always a great place to start. But what I was talking about here in the struct crossrefs, we can see this gets written in game thread start, and it gets read in two different subroutines. So if we look here, so like this was at offset 4, and here, so we don't see anything like that at offset 4, but at offset 8 we see, okay, we see something that gets read at 2 spots, but we don't see it get written. Now, this could still be the same thing, because the reason it might not be catching the place where it's written is because it might be after a malloc, and the type of it might not be set. So, a thing I can do for that, Laser Manager. We find operator new. This is also always a thing that's going to, or this is usually a thing that's going to be annotated. If you don't see operator new, look for initialize, and then whatever function calls initialize is probably operator new. It'll be the function that has a malloc. And so right here, we see that there's a malloc. Now I'm going to press T, oops, not T, I'm going to press I to change the IL we're seeing. Let's change it to medium level IL. Okay, so now we can see this variable. We can see the variable type returned by malloc, and in fact it is annotated. I thought that this was going to be void pointer, but it is struct z laser manager pointer. Interesting. And let's see the place in game thread start. Okay, interesting. So I don't know why we don't see the right to this variable in Touhou 14. Yeah, so sometimes you'll run into inconsistencies like that. So actually, I don't know if this, I mean, it looks like this is on tick and this is on draw. And in fact, if we look at these, we see, no. Oh wait, yes, okay. So if you look at the actual crossref, and I want to get this back to disassembly, I keep, okay. So if we look at the actual things, these are very similar. And so that's a pretty good sign that it's the same thing. But anyways, so Guy was asking about the laser list. So I happen to know that the laser list is iterated over in onTick, and you probably could guess that it would have to do this. You know, that kind of makes sense that onTick or the laser manager onTick function would have to iterate over the things. Okay, by the way, I've been talking about this on, or when I say onTick, I'm talking about two different things. Previously, I was talking about this field that stores the function. I was just using this as an example of a thing to relate between two games, because I wanted to go in and just do this update func on tick, because I think that's right. I'm not 100% sure if that's right. I would have to I would have to look at more of the context. That's what I want to do. But now I'm talking about something else. Okay, so we're talking about the laser list, right? In Touhou 17, I've got annotated this list, and so what the game does is it has a laser stored on Laser Manager. This is just a dummy laser that is never used. And it's what the very last laser in the list points to. It's kind of dumb, but it's basically so that the list is never empty, and so it can always prepend to the list without having to check if it's null, basically. So this right here is the thing that we're interested in, this list head. And so what I was talking about with the onTick is that is the most likely place where we will be able to find where this is modified. So I'm going to go to the function laser manager onTick. So right here, so we can see it actually goes backwards through the laser list. It uses the previous pointer instead of the next pointer. Just a weird thing that it does in this game. So right here, so now we're in Touhou 14. I'm going to go to Laser Manager onTick. And now we can see it's a little bit different. Okay, so Touhou 17 has onTick and onTick body. It checks this flag on GameThread pointer, and then based on that, it either calls this function or it changes game speed and calls this function. That's a little weird. But so we know that in Touhou 14, the check for the flag is right here. Oh, okay. Sorry, it's not different. It's not different. This is okay. It's the same thing. The method is calling twice here is laser manager onTick body. Okay, so now we have the same function in both of these games, laser manager onTick body. And I'm going to just annotate this. So right here, we see in Touhou 17, it reads the previous laser from address 14. And here it reads it from address 18. So that right there, we already have the offset that you need for the laser. Now, because in my notes I have this stored as a separate struct, it's not so easy for me to add that, because what I need to know is, did the okay, so let's go to struct laser. What I need to know is, did that offset change because the fields of laser changed? You know, like, did the offset of prev in laser change, or did the offset of the laser in the laser manager change? And actually, we're going to get an answer to that question very soon, because we're going to be able to see now. Let's go take a look at the place where it reads the prev pointer. So let's get back to onTick body. Okay, so right here, we can see this. So it reads one thing, it tests some bit flags on it, it reads another thing, and that's the previous pointer. So let's see. In Touhou 14, it reads one thing, tests some flags on it, reads another thing. This must be the next pointer. On the laser, we can annotate this as or ESI is Z laser. I don't have Z laser in this game, so we're going to say, whoops, what did I just do? Z laser. Oh, this is new. I don't know how big Z laser is in this game. I'm going to put 600 as a guess. And I'm going to actually just look for the place that allocates a new laser. So, laser manager, allocate new laser, laser manager, allocate new laser. Okay. This one is also, so this function is also frequently annotated because I need it for, or I have to bin hack this function in bullet cap. That's the reason why you will always find this function annotated. So if we look at the place where it annotates a laser, oh, lasers are different sizes, right? Oh, this is the most bullshit thing. Okay, sorry. Okay, a laser is 5CO. You just want to look for a memset 0. Because all this stuff up here, these are timers, basically. Zune's timer class has a constructor, or no, sorry, not a constructor, a default value initializer in C++ that disables a bit flag, and so you'll always see code like this. But then there's just a memset 0, because Zune puts at the very beginning of the constructor for this type something equals 0. So there's all this code doing this pointless initialization, and then we set everything to 0. But so that's the size of the laser base class, 5C0. So I'll just right, it's not, so I called this type laser, it's actually laser base class. And this, we're going to add a field. All right, that's a little annoying. That's a little annoying. Oh, I bet if I annotate this, or no, annotate this guy. There we go. Okay, so the padding actually is only useless stuff. That's neat. The padding is the padding inserted by Binary Ninja, and so all the stuff in here is probably just a big array of stuff. That's really cool. So yeah, here's all the fields, and we can put the Okay, so what was I doing? It was just this right here, right? So I was labeling this Z laser base class. So offset 8, and I'm pressing the back button on my mouse. We were right here. Offset 8 is the same thing. Okay. So Z laser base class prev, Z laser base class prev. Okay. So Z laser base class prev. And what we have here, Z laser base class, next, next. And the size, that was 5CO, was it? If I look at allocate new laser. None of this is stuff that Guy has to worry about. This is just stuff that I'm doing right now because I like having these parts of the notes filled out. It was laser base class constructor 5CO. Okay, so laser base class is size 5CO. And if you want to double check that the mem set actually is the size, we could just look at another game. Find laser base class constructor and see, is the mem set length equal to the size of the base class? Yes, it is. Okay, so probably it's zeroing the entire struct here. So we can set this size to in Binary Ninja, you press L, 5C0 is what we want. Touhou 14. Was that right? Why am I on Laser Manager on tick right now? I was in Allocate New Laser. Constructor, 5CO. Okay. All right. So now I'm trying to get back to on tick body. Okay. So in Laser Manager now, what? Oh, is that what happened? Hang on. I pressed the S key when I had this highlighted. It defined variables for all the fields. That's what it did. Okay. No, that's not. And that's just plain inaccurate. Offset 0, Binary Ninja has weird things with offset 0, where it often thinks it's a pointer to the type itself, and it isn't. That's the on tick on draw. So what? Okay, so anyways, right? Back to this. The offset of the next laser was the same in these both games, right? 8. And now we're going to on tick body. I have 2 underscores when there is something that's like describing the relation of one function to another. You know, like as in this is the body of on tick rather than this is on the ticking of a body. Okay, so this is offset 8 on the laser, right, in both of these games. But the initial one is offset 14 in this game and 18 in this game. So what that tells us is that so if we go to laser manager, yeah, these are actually really not helpful right now because they're supposed to be on our, yeah, I'm just undefining all of these. Why is it showing it like that? That's so the base class is right here at offset C in this game. It must be at offset 10 in the other game. So I'll put 10 here. Oh, let's press Y, copy, Y, oops, Y, paste. And so now we see this, everything is linked up now. Okay. Right, so that's how we get the, that's how we would get the laser base class. Or that's how we would get the laser list. I'll show one other example because Touhou so Touhou 14, it looks like it's very similar to Touhou 13. Oh, well actually no, let's do 15 and 16. Okay. 15 and 16 is the same size. It looks like it's probably the same struct. So what I'm going to do, okay, I saved both of these and we can close them. Now, I'm just showing this because this is something that, like, if you would like me to do it for a struct in a certain game, just ask me, and it probably won't take me too much effort, and it could save you a bunch of time. I have a script for importing a struct from one game to another, and it will recursively import all of the structs inside of it. So Touhou 16's laser manager is pretty well annotated. The one in Touhou 15 is not. Okay, let's get rid of this filler. All right. And so let's just take a look at ontick between these two games. Laser manager ontick. We could already see from the stats that these two structs have the same size. I'm not sure what 1552 is in hexadecimal. Actually, I don't know why I print this in decimal. because I have a much easier time reading hexadecimal for sizes. Anyways, ontic body. Okay, so does everything look kind of basically the same between these? Yeah, it kind of does. Oh, wait, what's going on? Okay, plus 10. Well, okay, so I don't know about this part. Anyways, I think they're similar enough that I'm going to try using the import script, and we will see how well it works. We're going to see if we end up with stuff like this, getting all annotated and looking beautiful. Hopefully we will. So let's see if I can remember the syntax for this. So I have Touhou reverse. And if you want to do this yourself, I think yeah, these scripts are somewhere on my GitHub. I'll link them in the description. You can add these to your plugins folder in Binary Ninja if you want to try this yourself. You'll have to ask me for my Binary Ninja database files. But import struct import type bv source. Okay, so so make sure we're in Touhou 15. We're importing it from 16. And what's the other thing? Oh, the struct name, duh. Z laser manager. And then we're going to look in the log to see what this ends up doing. Okay, Z laser manager already exists. Okay, I'll just undefine this type by pressing U. Alright, so imported vtable laser. Laser inner 48. Oh, that's probably bullet EX, and it's just not labeled correctly in here. This would be an element, or when I call something inner and then a number, it's the item of an array where the items are this size. So this is probably bullet EX data. Touhou 16 does not have the best notes. And that it can be a downside to importing, because if I have incomplete stuff in one game, I import incomplete stuff to another game. But anyways, we can take a look at what we imported. So like right here, we see it got. Well, actually, let's take a look at this right now. And Z laser manager, just annotate this function. So let's see if, for instance, we get, yeah, like right here, decrement list length. Ooh, it looks like this is erasing something from a list. It's calling a method on the V table. This all looks pretty good. Yeah, I would say most likely the stuff we imported is correct, and I don't need to look too intensely over it. So yeah, and that gives us a decent amount of. Oh, this is yeah, because here's the at x index. This is absolutely the bullet EX. It's just I forgot what I named it in other games. So if I wanted to fix it, I don't know what to name it right now. It could be like, do I call it bullet EX? That seems like a thing I call things, yes, okay. That doesn't even exist in Touhou, in my notes for Touhou 15, okay. Alright. Then I'll just call this zbullet EX. Oh, Control N, no. Click this, Control N, zbullet EX. Yeah, it's got a timer, it's got some ints, it's got some floats. I should change that. Yeah, see, now I have to change it here too. And this is why so much stuff is incomplete in my database, because if I want to fix something, it's not so easy to fix it in all of the games. You know, like I'd have to write a script that iterates over all the games, and I have some helper scripts for this, but sometimes automating these things is scary. Bullet EX. And I should probably just, like, in fact, I should probably just delete this from this game and import it from Touhou 17. In fact, I'm going to do that. Import type Touhou 17 zbullet EX. I haven't opened Touhou 17 in a while, apparently. Oh, oh, I don't see a timer there. Oh, it's EX state. It's EX state. And this is why I don't just randomly label things that I think I know what they are, because I can be wrong. So laser manager, or laser. So let's import zbullet EX state. Well, this is bullet. Oh, this is laser base class. Okay. Zbullet EX state was not found in source BV. Oh, because in Touhou 17 I named them differently for each EX. In Touhou 17 I have so Zune puts them in an array, and I have no idea why he does this. This is the state for each EX, but each type of EX goes in its own fixed spot. So I don't know why he has an array of this, of things with because they're all the same thing. They're all a timer, then 5 floats, then a 3 vector, and then 5 integers. And he just uses the fields randomly, whichever ones a given thing needs. It's like, dude, your bullet struct would be so much smaller and you would save so much memory if you didn't do this. Why do you do this? Well, why don't you just have fields for the move? Why do you have a universal struct that has 5 floats, well, 8 floats, 5 integers, and a timer? Why? But who cares? It's Zune. We don't have to. my headset died. We don't have to know why he does things. He just does things. I got sidetracked. Anyways, I think I wanted to show everything I wanted to show, except for the fact that right now this is wrong, and I have to fix this. This should be zbullet ex state. No, you know what? I'm not going to make that change at all, because right now, what I should do is I should look at a game where I have laser annotated better, and where I don't have that stupid inner 48 type. So if I just look for Z laser inner 48, okay, that's in those games. So let's try, let's look at laser base class. Let's find a game that has it pretty thoroughly annotated, but one which doesn't have laser inner 48. So Touhou 18 has almost all good bytes. So looks like I might have gotten it right in UM. Let's take a look at UM. Whoa, what's going on here? This looks like executable code. Oh, we're in hex view. Why are we in hex view? I don't use hex view for literally anything. Right. I got distracted. Laser base class. It's X state. Okay. So, do I have an X state base class defined here? If I just have bullet ex state. No. I'm going to define one in Touhou 18. Oops. I renamed that. I didn't want to do that. So copy, click out of here, press, nope. You used to be able to click out of here and press Y to define new types, but now you press out of here and it's S? No, it's not S. Create new types I. It's I. Okay. So I just copy this type, and this is what I imagine this type is actually defined, how it's actually defined in Zune's code. M, N, because he seems to love these letters for floats. What are the other ones he uses? RS? MNRS? And then another one. Who knows? This is... The 3 vector is... Oh, do I have 99 unassigned here? 99 unassigned. This is the base class. Right, hang on. That was dumb. What I should have done was... I should have called this ex state, or I could call it ex state We'll just call it ExState. But right now, I think I have a type with that name. No, I don't. Okay. And then, so we see it starts with the timer. The float 3 is at offset 28. Oh, and then there's 4. Nope, this is 5. This is 5 floats. I have no idea what to call these. But I assume Zune calls them just one-letter things. Almost certainly. Yeah. Oh. This is a float 3 at 1C. This has integers. Wait, are these integers? These ain't... You're not integers. Speed? Angle? There are issues in my notes, okay? Make no mistake. There are errors. I'm surprised this has no crossrefs. Given that I labeled this type, you would think I would have labeled a pointer somewhere to it so that I would get crossrefs. These have to be wrong. But anyways, so the location of this vector is different. And that bothers me because I thought the 3 vector was part of the definition of the base class. Maybe it's not. So, see, I don't know. I don't know. One, 2, 3, 4, 5, 6, 7, 8. Okay, zbullet ExState. So now, in order to get this, or in order to fix all the crossrefs in other games, I'm going to rename this. Then delete it. Then, okay, I have to save on here first. Okay. Which one did I delete it in? It looks like it was this one. So now we'll import this from Touhou 18. Zbullet ExState. Okay. And let's see, do we have the 99? No, we don't. Okay. Hello? What is this? What is this from? What? No, 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 no. That is not at all what I have. No! Oh my god, does Binary Ninja cache? I don't think it's reading from the file. That's a shitty change. Hang on. It's all fucked up. $17, 18. Cbullet ex state. Okay, undefine. Okay, zbullet ex state. Hey! Am I crazy? Am I crazy? This is not what I had. Am I crazy? Save. Am I crazy? I'm crazy. Okay. I must have confused myself and I was looking at the wrong database. Anyways, kind of shitty note to end things on. I don't even remember what game I was working on in the first place. Yeah, this guy. Right, I imported... Didn't I import the whole... No, I imported it into 15. So 15 and 16 were similar, that's right. So 16 had it wrong. So let's see. Laser inner, not there. Bullet ex state. Okay, undefine import Touhou 18 bullet ex state. All right, and then laser This is not bullet EX. This is bullet EX state. Perfect. I would love to ask an AI to try and make all of my notes consistent between the games. An AI is reaching the point where I think it could do it. But it takes, for me right now, it takes a lot of effort, and I tried to make an editor to make it easier for me to modify things between multiple games, and never really got far with that idea. Spent a lot of time learning React and what's the other one? Vue. And I don't think I could build it in Vue. I don't think the mutation model would work for it. It's just a mess. Okay, anyways. So now the one in Touhou 16 is good. I'll save again just in case. Although there's no circle there. So Touhou 15 is missing laser base class? Oh yeah, because the laser manager is empty. This was supposed to be 16. Okay, so importing from 16 to 15, laser manager gives us laser base class. Here's the correct EX state. And we can take a look in laser on laser manager on tick body. Annotate this. The type of ECX. And see that it's calling method, decrementing list length, doing those to, yeah, this totally looks like it's, yeah. And then it calls the onTick method for the lasers. Yeah, so this totally looks right. So I think the notes that we imported from Touhou 16 are good, especially since was laser manager the same size? 15, 16, yes. Yeah. Okay. So that is all. I know that this was a bit scatterbrained, and the answer to Guy's question was fairly short and early in the video. 18 or just onTick body, offset of the first laser, offset of the dex lasers. But yeah, that's generally what you want to do. And like I said, the methods that are most well labeled in these games are onTick, onDraw, initialize, constructor. I actually have keybinds for all of these. My headset died again. I actually have key binds for all of these things. So and VM constructor, where does this get called? Okay, that's not a good one. Bullet manager constructor. This gets called, should get called from, oh, it doesn't get called because it gets inlined. Ontic is an easy one. Okay, so basically these are so common that or it's so common that I have to label these that I have a key bind. So like if this thing was not, or if this thing was named or not named at all, just some random garbage, I hit a FT, and that's my keybind for naming an ontic. It'll look at this function name, take the class name from the beginning, use it here. It'll look at this method, it'll see, oh, this is just a jump. So we're actually going to call this one ontic, and we're going to call this one a stub. And it does all that. The other ones, the other similar ones, okay, here's a list of all the methods that you can expect to be defined in basically every game, because they're part of my initial reverse engineering on any game, going through the ontics and stuff. So yeah, destructor, on cleanup, on registration. These are pretty rare. Oh, I don't have thread start here. Thread start is definitely something you will see labeled. Okay. Yeah, I think that's it. Boy!